Hello students, I am Dr. Dhirendra Sharma, Department of Chemistry, Bundelkhand University, Jhansi. Today I am discuss here a important topic in chemistry, the chemical kinetic. Chemical kinetic is the very important for UG and PG classes. This topic they are discussed here, the UG courses BSc first semester. Chemical kinetic is very important role play in the chemistry, and also MSc courses MSc first semester chemical kinetic is very important for the our course. So, I am discuss here chemical kinetic. So, I am going to the board and discuss the chemical kinetic and what is the chemical kinetic and applications of chemical kinetic. Okay. So, listen. Here I am discuss the important topics chemical kinetic. Chemical kinetic, the study of thermodynamics and kinetic. Most of the chemical reactions are explained in both of the properties. Chemical kinetics is the very important role play in the chemical reactions. With the help of thermodynamics, I am study the concentration of the reactant molecules. Okay. So, in this topic, the first of all, what is the rate of reaction? Rate of reaction, it is also known as velocity of constant, velocity of reaction. Rate of reaction or velocity of reaction. Okay. First of all, velocity of reaction and rate of reaction. Okay. So, rate of reactions in this topic, the per unit time taking part of the reactant molecule is known as rate of reaction or and velocity of reaction. Means per unit 1 unit time reactant molecule convert into the product per unit time is called a rate of reaction and velocity of reaction. It is denoted by the symbol dx upon dt, bx upon dt or r. Some of the authors are represented by the symbol r, some of the dx upon dt. Okay. Above, and I am explain in the reaction, reactant A gives product. Reactant A, this is reactant. In this reaction, the initial concentration of reactant is small a mole, and this is the 0. Okay. And after time t, seconds, the x mole of the reactant decompose to form product, and the rest of the amount is a minus x and here x molecules. Okay. According to law of mass action, rate of reaction is directly proportional to concentration of the reactant. Rate of reaction is directly proportional to concentration of the reactant. The rate of reaction represented by dx upon dt is directly proportional to concentration of the reactant A minus x, okay, or rate of reaction is equal to K A minus x, where K is rate constant. It is also known as velocity of constant. Rate constant or velocity of reaction. In this reaction, if the concentration A minus x is equal to 1, above derivation the concentration of x extended A minus x equal to 1, then rate of reaction dt is equal to K A minus x is 1, then dx upon dt is equal to K, this one. If concentration is 1, the rate of reaction is directly equal to rate constant. This is known as rate law, also known as the rate law. This is rate of reaction and rate constant is the rate law. Okay. Next topic is this related factor affecting on the rate of reaction or velocity of reaction. Okay. So, factor affecting on rate of reaction या velocity of reaction. Okay. What main factor affecting on the rate of reactions or velocity of reactions? So many factors are involved in this topic, in this related. Okay. Number 1, nature of reactant. First of all, what is the nature of the reactant? So, reactants though have a strong molecular bond between the atomic molecules. So, these reactions are very slow, because breakup of the bond, so many energy are introduced and absorbed. So, nature of the reactants, weak molecules या weak reactant molecules are easily to break up, and जो strong molecules are atoms not is ready. This is what. Second time, temperature. Temperature is the another important factor to affect the rate of reactions. Most of the chemical reactions increase the temperature increase, and decrease and temperature decrease. Okay. So, temperature is the important factor to affect the rate of reactions. Mainly temperature increase, the rate of reaction only increase, or temperature decrease, the rate of reaction only decreases. Okay. Third, concentration. Concentration is the another part to affect the rate of reactions. The most of the concentration of the reactant are increased, the rate of reaction are generally increased. Okay. And then concentration of reactant are decreased as low, so then is reaction between slow. Okay. 4th point, pressure. Pressure generally affect the those reactions. This is liquid or gaseous state. Okay. Solid reactions, in the solid reactions are pressure are not affected by the reactions, but liquid or gaseous state reactant molecule are involved in the reactions. So, the pressure has the affected. So, pressure generally increase, the rate of reaction also increase, and pressure generally decrease, so rate of reaction also decrease. Okay. So, nature of reactant, temperature, concentration, pressure, and another point is catalyst. Catalyst. Catalyst is the important part. This the affect the chemical reactions, velocity of reaction. Most we know that catalyst, the presence of catalyst, the rate of reaction generally increase, and some of the catalysts are decrease the chemical reaction, but catalyst, it is a positive catalyst present in the chemical reactions. So, generally rate of reaction are generally increase. Okay. So, it depends upon the catalyst, which type of catalyst used in the chemical reactions. Generally positive catalysts are used, to then rate of reaction generally increase, and some of the reactions are negative catalyst used. So, rate of reaction are generally decrease. So, catalyst another factor affect on the chemical reactions. Okay. So, some main important part of the chemical reactions is affect the rate of reaction, generally nature of reactant, pressure, temperature, concentration, and another catalyst. Okay. And another part of the chemical kinetic is what is the molecularity of reaction. Molecularity of reaction. Molecularity of reaction. What is the molecularity of reactions? We know that in a chemical reactions, number of reactant molecules part of the chemical reactions, taking part of the chemical reactions is known as molecularity of reaction. The number of reactant molecule taking part in a chemical reactions generally known as molecularity of reaction. Here molecularity of reaction divided into three parts, type of three parts. Number 1, type of molecularity of reaction. Number 1, unimolecular reactions. Unimolecular reactions, those reactions only one reactant molecule part in the chemical reactions are known as unimolecular reactions. Only one reactant taking part in a chemical reactions are known as unimolecular reactions. That is example. For example, this is bromine molecules convert into bromine atom. Bromine molecule convert into bromine atom. This is the photochemical reactions generally, and this is the bromine molecule convert into atoms. So, this is reaction is unimolecular reactions. And another example of this type of reaction, malic acid. This is malic acid. Malic acid convert into fumaric acid this is malic acid and this is fumaric acid. Malic acid convert into fumaric acid is the another example of unimolecular reaction. This type of reaction generally study in the stereochemistry of ordinary molecules. We know the study in the 12th classes and another 11th, 12th. This is the stereochemistry, that the malic acid and convert into fumaric acid is the another example of is the unimolecular reactions. Second, bimolecular reaction. Bi means generally explained on the word as bi means two molecules. So, two reactant molecules part in the chemical reactions are known as bimolecular reactions. Only two, not three, not one and not another two or three. So, only two molecules taking part in a chemical reactions are known as bimolecular reactions. So, so many example of bimolecular reactions generally inversion of cane sugar, inversion of cane sugar, C12 H22 O11 plus H2O gives C6 H12 O6 plus C6 H12 O6. C12 H22 O11 is a cane sugar molecule, cane sugar, this is water molecule and this is glucose and this is fructose. Okay. So, this is the inversion of cane sugar is the example of bimolecular reaction, and another example of hydrolysis of an ester, hydrolysis of an ester. Generally ethyl ester, ethyl acetate CH3 COO C2H5 plus H2O gives CH3 COOH plus C2H5OH. Generally this is ethyl acetate, this is acetic acid and this is ethyl alcohol. Okay. This is the another example of bimolecular reaction. Okay. And the inversion of cane sugar, number 1 a cane sugar, or number 2 this is hydrolysis of an ester, or so many example of bimolecular reactions, but here discuss here only two examples. So, taking part in the reaction cane sugar and ester molecules and reaction proceed out. Okay. This is clear. Okay. Next, third, trimolecular reaction. Trimolecular reactions. Okay. Tri means generally name tri means three molecules. Three reactant molecules participate in the chemical reactions are known as trimolecular reactions. So, many example of trimolecular reaction. This is generally number 1 2NO2 plus O2 gives 2NO2. Sorry, 2NO trimolecular reactions. Okay. General example 2NO plus O2 gives 2NO2. Here only three molecules participate in the reaction, two nitroxide molecule and one oxygen molecules. 2NO plus O2 is equal to 2NO2. This is the trimolecular reactions. Okay. This is simplest form. Another example 2FeCl3 plus SnCl4 2FeCl3 plus SnCl4 Cl2 is equal to Cl2 2FeCl3 plus SnCl2 ठीक है gives 2FeCl3 plus SnCl2 2FeCl2 plus SnCl4. This is another example of trimolecular reactions. Okay. And so many example of trimolecular reactions in the books and available. Okay. So, they have discussed here the molecularity, three type of molecularity: unimolecular reaction, bimolecular reaction and trimolecular reactions. Okay. Another topic of the chemical kinetic very important, this is order of reaction. Order of reactions. This topic is very important for UG and PG classes. Many times are enter in the examinations hall, or this question are present order of reactions. So, order of reactions, what is the order of reaction? How to determine the order of reactions? Okay. So, order of reactions generally the determination of velocity of the reaction, the determination of velocity of the reaction with the help of number of reactant molecules in the reactions are known as order of reactions. Okay. So, the determination of order of reactions generally with the help of reacting molecule participate in the chemical reactions, whose concentration change during the reactions are known as order of reactions. Here is it divided into three parts, three or more generally. First order reactions. First order reactions. How to define first order reactions? Okay. So, first order reactions generally I am explaining this first order reaction. In this reaction, during the reaction only one reactant concentration change. In this reaction only one reactant, one or two or more reactant are participating in the chemical reaction, but only one reactant during the reaction change the concentration are known as first order reactions. In the reaction more than one or two reactant are present, but during the reaction only one reactant concentration change in the reactions are known as first order reaction. For example, I am considering here a reaction, reactant A convert into product. The initial concentration of the reactant A generally small a mole, and this is 0. And after time t, seconds, generally x moles of reactant A decomposed to form the product, and the left amount of the reactant A, this is A minus x, and product is a x, for example. Okay. According to law of mass action, according to law of mass action, we know that law of mass action, rate of chemical reaction, is directly proportional to concentration of the reaction, concentration of the reactant. Okay. Law of mass action known as rate of chemical reaction directly proportional to concentration of the reactant. The rate of reaction represented by dx upon dt is directly proportional to concentration of the reactant A minus x, or dx upon dt is equal to k 1 A minus x, where k 1 is rate constant for first order reaction. K 1 is equal to first order reaction. Okay. So, this is the first order reaction, and another representation of the first order reactions, the rate of reaction dx upon dt is proportional to concentration of A, this is one Ca, or dx upon dt is equal to K1 Ca. This is where K is 1 is the rate constant. Okay. This is the mathematical representation of first order reactions. Here dx upon dt is the rate of reactions and K1 is the rate constant. Ca, C means concentration, A means reactant. So, this is the Ca represent the concentration of reactant A. Okay. The example of first order reactions: inversion of cane sugar, inversion of cane sugar. Inversion means this is the I am discussing for some time. This is C12 H22 O11. This is cane sugar plus H2O. Here this reaction H2 is the n axis, gives C6 H12 O6 plus C6 H12 O6. This is glucose and this is fructose. In this reaction, inversion of cane sugar, the water molecule in the excess amount. So, the concentration of water molecule no change during the reaction, but reactant cane sugar molecules are change the concentration convert into glucose and fructose. So, this reaction is known as first order reaction, but the molecularity of the reactions is the 2. This reactions molecularity of reactions is a 2, because 2 molecules participate in the reactions. One is cane sugar molecule and second is water molecule. So, the molecularity is 2, but the order of reaction only 1, because water molecule present in this reaction excess amount. So, the concentration of water molecules are no change during the reactions, but cane sugar molecule change the concentration to form the glucose and fructose. So, this the inversion of cane sugar is the another example. Second, hydrolysis of ester, hydrolysis of an ester, ethyl acetate CH3 COO C2H5 hydrolyze to give acetic acid CH3 COOH plus C2H5 OH. Here water molecule another excess form, this is ethyl acetate and this is gives to acetic acid and ethanol या ethyl alcohol. Okay. So, this is another example of first order reaction. In this reaction, ethyl acetate hydrolyzed to give acetic acid and ethanol, and in this reaction water and another excess form present. So, during the reactions the only one reactant molecules ethyl acetate change the concentration to form acetic acid and ethanol. So, the reaction is another form of the example of first order reaction, but in this reaction also the molecularity of the reaction 2. This the one is ethyl acetate molecule and second water molecule. So, 2 reactant molecule participate in the chemical reactions. So, the molecularity of this reaction is a 2, but the order of reaction is a 1. Okay, clear. So, this is the main confusion of so many students are what is the difference between molecularity and order of reactions. So, molecularity is the taking part of the reactant molecule in the chemical reactions, but order is the those reactant molecule the change in concentration during the reactions are known as order of reactions. So, main basic concept is what is the reactant molecule participate or what is the concentration change during the reactions. Okay. So, taking part is 2 molecules. So, the reactant is a second bimolecular reactions, second order reactions, first order reactions sorry. So, in the reactions water molecule in the axis. So, this is not affect the rate of reactions. So, this is the hydrolysis is the first order reaction example. Okay. Second order reaction. Second order reactions. What is the second orders? This is the known as the second. Second means two reactant molecule. So, those reactions, the rate of reactions, okay, determined by the two reactant molecules, those concentration change the during the reactions are known as second order reactions. Okay. For example, the reactions is a two cases, reactant A plus A gives product. In this reaction, reactant are same, A plus A, this is reactant only, but both of the reactant are the same. Okay. This is the second order reaction. So, the rate of reactions, initial concentration कह सकते हैं आप. What is the initial concentration is small a and small a and small 0. Okay. And after time t, x mole decompose of reactant to form product. So, left amount is the A minus x and another A minus x is equal to 2x after time t. According to law of mass action, according to law of mass action, according to law of mass action, rate of chemical reactions is directly proportional to concentration of the reactant. So, rate of reaction dependently R is proportional to concentration, this is C A into C A, or R is equal to K 2 C square A, where K 2 is equal to rate constant. Okay. This case only two reactants, okay, two reactants are same. Okay. And another second half case, this is the reactant are different, A plus B gives A B. The rate of reactions dx upon dt is proportional to C A into C B, or dx upon dt is proportional to is equal to K 2 C A into C B. This is the two cases of second order reactions. First case, the both reactants are same, and second case, the both reactions are different. So, C A and C B are order. The example, what is the example of second order reaction? Saponification of ester, CH3 COO C2H5 plus NaOH gives CH3 COO CH3 COO Na plus C2H5OH. This is sodium acetate. This reaction is also known as second order reactions, because the first molecule ethyl acetate and second molecule sodium hydroxide, that during the reaction the change in the concentration are known as second order reaction. Okay. Next, third order reaction. Third order reaction. We know that the third order reactions generally explain the determine the rate of reaction or velocity of the reactions with the help of number of reactant molecules participate in the during the reactions. The number of reactant molecules change the concentration during the reactions are known as third reaction order. Generally, three cases are where number one, A plus A plus A is gives product. In this case, all the reactants are same case. Second case, A plus B. Two reactants are same and third is different. And case third, A plus B plus C gives product. All the reactants are different. Okay. So, three cases of third order reaction. In case first, all the reactants are same. In the case second, two reactants same, but second is only, third is different. And case third, all the reactants are different. So, three cases are possible in third order reaction. The rate of reaction is proportional to concentration of the reactant according to law of mass action. So, dx upon dt is proportional to C A into C A into C A is equal to K 3 C Q A. This is K 3 is the rate constant, a velocity constant for third order reaction. Okay. And case second, the rate of reaction dx upon dt is proportional to C A into C A into C B is equal to K 3 C square A dot C B. Okay. And case third, the three are different, dx upon dt is equal to C A into C B into C C. Then rate of reactions K 3 C A into C B into C C. Okay. Okay. The example of third order reaction. The more famous example of the third order reactions are known as 2FeCl3 plus SnCl2 gives 2FeCl2 plus SnCl4. This is the most famous example of the third order reactions. Okay. According to law of mass action, rate of reaction is proportional to active mass of FeCl3 square dot active mass SnCl2, or rate of reaction dx upon dt is equal to K 3 FeCl3 का square and SnCl2. Okay. This is the third order reaction. The order of reaction in this reaction is equal to reactant 2 plus 1 is equal to 3. This is the third order reactions. Okay. So, here discuss the third order reactions. Okay. This is the most famous topic of the chemistry, chemical kinetics, general topic of molecularity and order of reactions. Okay. Thank you very much. And our next topic is another topic. I am continue the next lectures. Thank you, students. Thank you very much.